Alright guys, so this is the first test review I'm going to do a video for. They will all be links on the classroom that go to the YouTube page I have. And they pretty much just go over the review again like we did in class, but if you're ever absent or need to go back over something, you can kind of look through this. Because there's so much writing on this one, I'm going to take the answer key here and just kind of go through some things, mention some things. So this one should not be as much of me writing, kind of me more explaining. But I will point to some things and stuff like that. So right off the bat, we're looking at turning the statement into a conditional. We have all horses are mammals. So remember, I'm going to make this a little bit larger. The horses part, that's your hypothesis. The mammals, that's the conclusion. And remember that you have to have the two parts in every sentence, right? You can't make this all one thing if all horses are mammals, because then there's nothing to conclude. So again, remember your sentence can have slight differences, but if it is a horse, then it is a mammal. That's a simple one. If you have a horse, then you have a mammal. If I have a horse, then I have a mammal, something like that. And that statement's true. Not much more to do there. Converse, you have the flip, right? Converse is if Q, then P. So we take what was the conclusion and put it to front. If it is a mammal, then the hypothesis to the back, it is a horse, okay? And of course with that, that statement by itself, not true, because as you can see here, we said, for instance, I have a mammal, so the first part's true, but the mammal's a dog, right? You can have mammals that are not just a horse, but when you write the explanation, please remember to be specific and never just say, well, I have a mammal that's not a horse. Be specific, give examples, it's better for what we're doing. So then the inverse is a negation. So it's not P, then not Q. We also use that squiggly line, of course, to reference that. And that just happens to be false because you could have something that's not a horse like a dog, but that's a mammal, right? So the first part true, making the second part different. Contrapositive, if it is not a mammal, then it is not a horse. Contrapositive is both the flip and the negation at the same time. If not Q, then not P. All right? And that's actually true. If you have something that's not a mammal, then it's definitely not a horse. It could be, a snake or other things, but it's not a horse, and that's true. Biconditional, remember it's the hypothesis, if and only if, and then the conclusion. No if then, just one if and only if the other. And for that to be true, you need both the conditional and the converse to be true, right? So you have to be able to say if P then Q is true, and the converse if Q then P is true. One of the nice things about having written this all out is we can clearly go back up to the top and see that the converse was false and say, okay, well then this is false, and the reason would be the same. Because in going backwards, if it is a mammal, then it is a horse. That's false, because, like we said in there could be a dog, it could be a monkey, it could be a cat, whatever. All right, then we go to the second one. It's pretty much the same thing, so I'm not going to go back through each and every one. But again, make sure we break up the conditional statement correctly. That's one of the key parts. All triangles, that's your hypothesis. Having three sides, that's your conclusion, right? So if it is a triangle, then it has three sides. And all these are true, by the way, because if you have a triangle, it has three sides. There's no ifs, ands, or buts either way. Converse, flip it. If it has three sides, then it is a triangle. Inverse, negative. If it is not a triangle, then it does not have three sides. Contrapositive, do both. If it does not have three sides, then it's not a triangle. And by conditional hypothesis, it is a triangle. If and only if. Conclusion, it has three sides. And all of that's true. Okay? So, just some reminders. The board will still be up tomorrow, so there's always the word wall. It's not technically, I guess it's technically cheating, but it's there. I'm not going to cover it. You still need to know how to use them. If you don't know what it's saying up there, then that doesn't help. Okay, this is video 1. Video 2 will be the back of the review. All right? All right. All right, here we are on page 2 of the review. So we'll go through these real quick. Again, you see the answers here, but I'll kind of explain them and walk through them. Number 3, these are symbolic representations of if-then statement. Remember, most importantly, that the arrow is telling you if-then. So these are literally saying if A, then B. If B, then C. If C, then D. So they're literally representing here 3 conditional statements, 3 if-thens. When you have multiple statements where the conclusion of one leads to the hypothesis of the next and so on, you're doing syllogism. That's the chain rule. The key there is to remember that the final conclusion is if the very first thing, then the very last thing, and that's what you see there. If A, then D. That should be your conclusion, okay, and that's why. Get that out of the way. Number 4. So I was saying number 4, if John reads a book, then Tom watches TV. If Tom watches TV, then John eats ice cream. So what they're saying here is, again, I have 2 conditional statements, 1, and that starts 2, and one leads to the other. It's syllogism again, literally the same thing, just with, with actual statements as opposed to number 3. So if the very first thing, then the very last thing, and it already tells you, John reads a book, so that happens, what can you conclude? Last conclusion. Oh, that is totally incorrect, isn't that? Well, that's embarrassing, and that means I should probably go change that. You should have Joe eats ice cream. Yeah. By the time you see that on the classroom, it'll be changed. But I'm making this video before I load stuff, so I'll go back and change that. So, see, always good to check your work. 5, how can you show that the following statement is false? If you play a sport, then you use a spherical ball. Explain. So again, we talked about this. You want to actually be playing a sport, but you want one without a spherical ball. And be specific. I play football, but the ball is oblong or, egg-shaped. I play hockey, which uses a puck and not a ball. I swim, which doesn't require a spherical ball. I participate in track, which doesn't require, other than shot put, but you don't got to be technical. I run track, right? The running part doesn't require that. So any example, just be specific and make sure you start that you're playing a sport. 6, give a counterexample to the following statement. If a number is divisible by 10, then it is divisible by 4. Again, counterexample. We need the first part to be true. I need a number that's divisible by 10, but not by 4. And when we mean divisible, mean when you divide the number by 10, it goes in evenly. But when you divide it by 4, you would get a decimal. So my example is 30. 30 divided by 10 is 3. 30 divided by 4 is 7.5. Okay, so not evenly. So 10, 50, honestly, any odd multiple of 10, 10, 30, 50, 70, 90, and so on would work. Okay? But again, it's a key that, what is key is that you start with that still being true. Just like the one before it, you had to make sure you were playing a sport first. That's key to counterexample. 7 and 8 are simply patterns. It's inductive reasoning. They shouldn't be super difficult patterns like this one, +3, +4, plus 5, plus 6. So, plus 7 is where we get 27, and that plus 8 is where we get 35. And there are the two numbers. Right, complete sentence. There you go. The next one, it's either the squares, 1 squared, 2 squared, 3 squared, and so on. So you would get 6 squared, which is 36, 7 squared, which is 49. The other way to look at that is a little more complicated. Plus 3, let's use a different color here. Right, so plus 3, plus 5, and you're increasing by an odd number, the next odd number, plus 7, plus 9. So 25 to 36 is 11, 36 to 49 is 13. Okay? Again, the pattern itself should not be too difficult. The main key here is to be able to identify one and to write out what you're doing, to write out where you're getting or to write out your answer, I guess, more specifically. All right, back up to number 9. Name the property that allows you the following statement. So these, another typo there, I realize. Again, if you're looking up the answer key, these will be fixed. It's the transitive, not transitional. Transitive property. But again, in that notebook, you need to go know these. A lot of you left your notebooks here. I'm looking at them right now. Not a good sign. I hope you know what know your properties. Number 10, what property allows you to say the following? So notice what they did is they took the 3, plugged it in here, and that's what gave you, when you plugged it in, that's substitution, literally substituting in the value. That's what the normal use of substitution is. We've seen other things for it, and that's fine. Then a couple of algebraic proofs here. So, of course, we're given this. You always start with what's given. And then here, given that x is 3, they plug it in. So that's literal substitution. That's the way we normally see it. As I said in class, these 3 steps could have easily be combined, because here they literally are just multiplying the 4 times 3. And here they're combining 135 and 12 to get the 157. It's all substitution. You could do it in one step. It doesn't really matter. It's a little cleaner if you do. Now, from here to the next step, they kind of then don't show you what they're doing. But notice they get rid of 157, and this number goes down to 99. You do that by subtracting the 157. So that's where you get subtraction property. They just didn't write it out. And then here, to get the y by itself, you divide by -3, and hence the division. So again, this one, a little bit different than what we've been seeing, but it's, it's still a property. You should still be able to identify what they're doing step by step as you go through this. I'm going to clear this back out. And then the last one's a little more like what we've been doing ourselves. You start with a given equation. What's the first thing they did? They multiplied this 5 out. You see 5x. They wrote it out. No big deal. Distributive property. Then they subtract x from both sides, subtraction. Then you do the subtraction. So, again, just so we're clear, the reason it's technically allowed to be called substitution, they are substituting the 5x and the minus x with 4x. So again, it's technically, you could call it simplifying, combining like terms, but you are substituting the simpler value for what you had there. Here, the x and the minus x cancels. That's why 30 is by itself. Then from here to here, you get the plus 10 plus 10. And again, that's addition. But then here, they actually cancel these out to 0. 30 and 10 is 40. You get the next step. Then you see them dividing by 4. That's division. And then they, again, simplify it, substitution. So hopefully y'all understand these. You should have a notebook. You have assignments. You have notes. You have this review. You have more than enough. I hope you utilize these videos, even if you know what you're doing. Not a bad idea to go back through it. All right, good luck. We'll see you tomorrow, and hope you do well on your tests.